Enzyme kinetics is the study of the rates at which enzymes catalyze chemical reactions. It involves investigating the mechanisms by which enzymes bind to substrates, facilitate chemical transformations, and release products. Understanding enzyme kinetics is crucial for elucidating the catalytic properties of enzymes and optimizing their applications in various fields such as biotechnology, medicine, and industrial processes. Here's how to measure enzyme activity in a laboratory setting. Prepare reagents and equipment. Gather the necessary reagents and equipment for the enzyme assay. This typically includes the enzyme of interest, substrates, buffer solution, cofactors or coenzymes, spectrophotometer or other assay equipment, cuvettes or microplates, and appropriate controls. Set up the assay. Design the enzyme assay to measure the conversion of substrate to product over time. Determine the optimal conditions for the assay, including pH, temperature, enzyme concentration, and substrate concentration. Prepare a series of reaction mixtures with varying enzyme and substrate concentrations to establish a standard curve and determine the linear range of the assay. Initiate the reaction. Mix the enzyme, substrate, and other components in the reaction mixture according to the assay protocol. Start the reaction by adding the enzyme to the reaction mixture or by initiating the reaction with a specific trigger, e.g., change in pH or temperature. Record the start time of the reaction. Monitor reaction progress. Monitor the progress of the enzyme-catalyzed reaction over time. Use a spectrophotometer or other assay equipment to measure changes in absorbance, fluorescence, or other optical properties of the reaction mixture. Take measurements at regular intervals to capture the kinetics of the reaction. Analyze data. Analyze the data obtained from the enzyme assay to determine the rate of the reaction and calculate enzyme activity. Plot the change in substrate concentration or product formation over time to generate a reaction progress curve. Use linear regression analysis to calculate the initial reaction rate and determine the enzyme activity under the specified assay conditions. Determine kinetic parameters. From the enzyme kinetics data, determine kinetic parameters such as the Michaelis-Menten constant, Km, maximum reaction velocity, Vmax, turnover number, kcat, and enzyme efficiency, kcat per kilometer. These parameters provide insights into the catalytic efficiency and substrate specificity of the enzyme. Control experiments. Include appropriate controls in the enzyme assay to account for background noise, non-enzymatic reactions, and other sources of variability. Negative controls without enzyme or substrate can help assess baseline levels, while positive controls with known enzyme activity can validate assay performance. Interpret results. Interpret the results of the enzyme assay in the context of the experimental conditions and objectives. Compare enzyme activity under different conditions, such as varying pH or substrate concentrations, to elucidate the factors that influence enzyme kinetics. Draw conclusions about the catalytic properties and regulatory mechanisms of the enzyme based on the experimental data. By following these steps, you can measure enzyme activity in a laboratory setting and investigate the kinetics of enzyme-catalyzed reactions. Enzyme kinetics studies provide valuable insights into the mechanisms of enzyme action and have important applications in basic research, drug discovery, and biotechnological processes.